Good morning, dear learners. Our topic for today's discussion is about mean and variance of a discrete random variable. So before we start our discussion, let us know first the target or objectives with this lesson. At the end of our lesson, you will be able to first illustrate a probability distribution for a discrete random variable and its properties, computes probabilities corresponding to a given random variable, illustrates the mean and variance of the discrete random variable, and lastly, calculates the mean and the variance of the discrete random variable. Okay, now before we proceed, let's have first a recap. Okay. So what is a random variable? It is the capacity that connects a real number with any component in a sample space. So it is something measurable or can be counted. So what is a discrete and a continuous random variable? So when we say discrete random variable, it is anything that is finite number of a distinct values. In a continuous random variable, it is something that is measurable. So as far as you can remember from our previous example, when we flip a coin, the number of times the coin has been flipped is an example of a discrete random variable. And when the amount of drinks or an amount or a medium-sized container, it is a continuous random variable. So always bear in mind that if it is a discrete random variable, then it is something countable. While in continuous, it is something measurable. So last time, we had an experiment of tossing a coin 4 times, in which these are the possible results. Out of the following results, we identify the random variable x. So the random variable x is the number of times the head appears. So in that case, in our first sample space, there is no head, so 0. In the second to fifth sample, we have 1 heads per sample space. Then, in our next sample, we have 2 heads. So as what you can see, we already have here the color coding for us to identify. So in the other examples, we have 3, and then in the last sample, we have 4 heads. So basically, if we talk about random variable, there is a chance that the value of x is equal to 0, 1, 2, 3, or 4. So if you can still remember, we call it mass points. So if this is the mass or what we call the values of random variable, where do we get it? Because when we flip a coin 4 times, then it is possible that we will get a 0 head, 1, 2, 3, or 4 heads in results or in the situation. Okay, now let's consider the number of heads. So we have 0, 1, 2, 3, and 4. So we call this mass points. Now what is a sample points? So these are the outcomes in which it will satisfy the number of heads that we consider in the heading. So if there is no head, so the outcome will be 4 tails. And if it's 1 head, then this will be the possible outcomes. So just simply look at the sample points in table 2. Okay, this will be the possible outcomes if 2, 3. And if there is 4 heads, then this will be the outcome. So look at the color coding of the sample points. So it means that the number of occurrence, if it's 0 head, then we have 1 sample point. If 1 head, we have 4 sample points. If it's 2, we have 6. If 3, we have 4. And if 4, we have 1 sample points. So we will now get the relative frequency, but in the form of fraction, or we can also do it in a decimal point. So this will serve as its probability based on the relative frequency. So what does it mean? So we will get its total by what? So 1 out of bilaman. So, di ba 16? So 1 out of 16 because there is 1 occurrence out of the 16 sample space. So this is the probability that we will get zero head in the outcome. Now, what will be our probability in one head? So, in 1 out of 4, so 1/4, because it's 4 out of 16. So, always remember that we always simplify if it's a fraction form. So, that's why we have 1/4. Now, in the third table, we have 2 heads. So, 6 out of 16, if we simplify it, it will now become 3, 8. Then in the outcome that has 3 heads, we have 4 occurrences. So that will be 4 out of 16 or 1/4. And in the end, we have 1 out of 16. Knowing all of those values, we had then removed the part of the sample points and the occurrence. So we have now the number of heads and the probability, or what we call values of the random variable and probability. We can now have the probability distribution. So what is probability distribution? So these are the set of all possible values of a random variable x, so the number of heads, together with the corresponding associated probabilities. So along with this two together, we can now form the probability distribution of x. Okay, now let's have another example. In a computer laboratory, the teacher wants to find out if there is a defective computer. Suppose 3 computers were tested at random. So we will test 3 computers and we will look for the defective computer. She asked one of her computer system servicing students to list all the possible outcomes, such as that D represents the defective computer and N represents the non defective computer. Okay, so let X be the random variable for the number of defective computers, then illustrate the probability distribution of the random variable X. So we already have here the list of possible outcomes because there is 3 defective computers, right? So we will going to identify its random variable or the number of defective. So there's a chance if we pick 3 of those, there's a chance that the 3 of them are not defective, so working very well. But it's also possible that there's one who is defective in the set of computer that we will choose. So it means that the possible values of the random variable in this case are 0, 1, 2, and 3. So for us to complete this distribution table, we will no longer make the table we have back then. Instead, we are going to identify if what are its values. So we have 8 different outcomes, right? So in the 8 different outcomes, how many are defective? So that's 1 out of 8. Now, 1 out of 8 or 0.125. Now, what about 1? So that's 3 over 8. So 0.375. If 2, so still are 3 over 8 or 0.375. And the last will be 1 out of 8 or 0.125. Now, what we have here is the values of random variable x or mass points and the probability. So this is what we call the probability distribution of discrete random variable. So the probability distribution of a discrete random variable x is a list of the possible values of x, the 1, 2, 3, and 1, 2, 4, and the corresponding probabilities of the values. These are the fractions and decimals in the second table. Okay, so next, we have to identify the characteristic of the probability mass function. So what are those? So try to observe the values of the probability in terms of the fraction. Okay, what type of fraction is that? So firstly, we will observe that it's positive. So it's a non-negative property or characteristic. What else? We can observe that they're all proper fraction, right? So it means that the value of the proper fraction is between 0 and 1. So if it's between 0 and 1, then that's when the probability of each value of the random variable must be between or equal to 0 and 1. So remember that a probability can be 0 or 1. 0 if it's impossible to happen, and 1 if it's sure to happen. In symbol, we write it in this way. Okay, so we have to satisfy the first property. So what's the first property again? The probability must be either 0 or 1. I mean like the probability must be either 0 or in between 0 and 1. Okay. So what else? So if you're going to look in this situation, there is still one property, right? So let's try to add all the probability. Okay, so try to add 1 8, 3 eighths, 3 eighths, and 1 8. If we add them, the total would be 8 out of 8, which is equal to 1. Now, we all know that 1/4 is equal to 4 out of 16. And 3 eighths is 4 out of 16. And 1/4 is 4 out of 16. So if we add 1 plus 4 plus 6 plus 4 plus 1, its total will be 16 out of 16 or 1 out of 16. So what does it mean? So it means that we have now our next property. It's the properties of it's the sum of all probabilities of all values of the random variable must be equal to 1. Okay, so it is evident to our first and second example. So in symbol, we write it as this one. So you can see on the screen. Okay. Now moving forward, let's try to answer this next example. So how are we going to apply it all? In what problem? So let's look at this problem or example. Determine if the distribution below is a discrete probability distribution. We do have a distribution, but how will we know if it's a probability distribution of discrete random variable? So syempre, you have to satisfy the two property. So let's look at the values. All of them are proper fractions. So it already satisfy the first property. What about the second property? So we are going to add all of this. Okay. So is it equal to 1? But the result is 5 over 3, so it is not equal to 1. So this is not a discrete probability distribution. Well, yes, it is a distribution, but it is not discrete. Okay, next, let's satisfy in decimal point. So how are we going to satisfy? So still the same, we are going to add them all for us to identify if it's a discrete probability distribution. So add all of the probability. The question is, will that be equal to 1? So yes, it is equal to 1. Therefore, it is a discrete probability distribution.